Good morning. It is time to work on day 5. I have already started. I started a little bit last night, mostly because I want to spend some time practicing getting the data structures right. And it's time consuming. So this was something I could do on the couch last night while watching a Christmas movie. So no stream last night, but what I'm going to cover today is what I've done so far in day 5. So let's first review what we're supposed to be doing. We are getting an input like this, which gives us a list of seeds. Then it gives us a seed to soil map, a soil to fertilizer map, a fertilizer to water map, etc. Then there's going to be one or more lines that have the source index and the destination index, as well as the range count. So this would be 50 and 51, correspond to 98 and 99. So, and all the rest of these are the same. So what we're supposed to do is find, at least in part 1, look at the soil number required for each initial seed number. So 79 corresponds to soil number 81, 14 to 14. This is the case where you don't have a range covered here. So let's see. First line has a destination range start of 50, source range start of 98. Oh, I have those backwards. That's I'm glad I read that. Okay, so I'm going to let me just close that for a second. Let me make sure I fix the input. So I started off with parsing seeds. So I grabbed just the seeds part of the input. And where'd my chat window go? There it is. So I just start with the seeds part of the input. And let me make this a little bigger. So going to parse seeds, this is using nom, and this is using it in the style that I think is more closely meant to how it's supposed to be. So here I just do the parsing. I don't actually unwrap anything like I did here. So it's just sort of all in one. So we're saying that we precede this with some terminated pair where it starts with seeds and ends with space 1. Now, normally terminated would discard the terminator and give you this. But because we're using this whole thing as the preceding element to this parser, this part gets thrown away entirely. And then what we're left with is a separated list of spaces as our separator and U32s. And then we call that on our input. We get back a vec of seeds. Seed is a type alias for U32, just to make the call site a little cleaner. Like for instance, right here, instead of saying seeds as a vec of U32, I can say vec of seed, which is pretty cool. And then this sort of also gives you a hint that the U32 that we're returning isn't a seed because I didn't name it seed. Okay, so that gives us our seeds. Then I want to parse ranges, and the ranges are going to be this part here. So I'm going to start with this number, then this number, and then this count. So that's what I'm doing here. Range 1 start, range 2 start, and a count. And I'm using a tuple parser. And a tuple parser will take n number of parsers as input and then return those to you. So here I'm saying I have a U32, which is terminated by a space, 1 or more. Again, and then this one is terminated by a line ending. But I'm just noticing that this one, let's actually check our input, make sure that none of these end in a space. I don't think they do. They all end on new lines. Okay. So this will give us range 1 start, range 2 start, and a count. And then I'm mapping those here to their actual to the actual ranges. So I start with range 1 and I go equal to range 1's start plus count. And the same thing for range 2. So that's pretty simple. Then we are parsing a source map. The source map type is a struct that has a name. So in this case, it would be like water to light. And then the map is the map from the source index to the destination index. So when we parse the source map, here we are getting the name out first. So this one is a terminated parser, takes everything until space map. So that becomes the extracted output, and then is terminated by a line ending. And then that gives us the rest of the input, which would be basically all of this. All right, so then we're using, and this one, it took me a while to get the syntax right, but luckily I knew what I was going for. So fold is like reduce in Swift or in other languages. So the idea here is we're going to take many parsers, and the output of that parser, we're going to continue to fold that into a value. So if I were to do this on multiple lines so you can see the different arguments, this is argument 1, which is the many parser that I'm going to be pulling out. So this is a parse ranges followed by a line ending. So that's here. And then as soon as I get to this, I'm done, right? So this blank space is what terminates this list, or what ends the many. So each one of those ranges gets put into this hashmap.new and calls this block. So we start off with this initial value, and then we go into this block here. We get the mutable reference to the map, and the range pair, which includes the start and destination. Well, destination and start. So where I'm going wrong here is that we are, and because I have 2 ranges, so here I might have a range from 14 to 16, and then this one might be 94 to 96. What I really want to do is iterate those in pairs. So I want 14 and 94 together, etc. And now we know that these are always going to be the same length, but an interesting technique to do this rather than iterate by indices is to zip. So zipping does exactly that. Each element of the iterator, it plucks one from here, one from there, puts it into a tuple, and then it moves on to the next one. So what we're doing is we're saying range pair dot 0, which is the first one, zip that with range pair dot 1, which is the second one. And each time through, we're going to get a pair. If I turn on inlay hints, you can see it's a U32 tuple. And now when we map those, I want one to be a key and one to be a value. So I'm just going to swap those because I want the source to be first. Okay, and then we return the map. So I really like how this ended up turning out. At the very end, we now have an entire hash map where the source is the source index, the destination is the destination index, and then we return that from here. So that's what I have so far. And if we go down to the tests, parse seeds, I can run this test and it should work. Yep. test parse source map needs the test macro. So if I run that test, that one fails. Let's make sure that, and then that's test sample input, which should result in 35, which is the result of part 1. So parsing the source map, let's see, where did that one fail? Okay. Unwrap error. This happened on line 81, so we couldn't parse it. And the input was this seed to soil map. Input. So it seemed to get a little farther than here. So I think what happened is it grabbed the name and then it failed on the fold many. So let's print line or debug name. I can have this run the tests over and over again. Let's do this one. Oh, one other thing I did is I added a just file. Just file is kind of like make, but more like it's way simpler and doesn't have a lot of makes quirks. So I can do just build to build it. I can do just test to test it. That requires me to add to add an argument, and I can also do just watch part 1, which will do all the no capture stuff that we talked about. Okay, so we're running 3 tests, and the 2 failed. Test parse source map failed. And did it print out the name? No. Did it print out anything? Make sure we're getting print output. Yes, okay. And then here, if I do name this, and we do not see it. So this first one failed. Okay. I don't know why I have 2 of those. Okay, so take until should take until the given sequence. Returns the input slice up to the first occurrence of the pattern. It doesn't consume the pattern. So here is until EOF is a parser that takes until EOF on the string. Until EOF hello comma world EOF will return the remaining string and then hello world. Okay, that's exactly what I thought it would be. Okay, so if I instead took a terminated alpha 1 and line ending, and then call that on input, would that give me everything including the map? Let's add import alpha 1 from character complete. That gives me oh, the dash, okay. So that would be alpha numeric 1. So here, and then there's also the Yeah, so this would be terminated alphanumeric 1 with a tag of that. And then a line ending. I'm not sure why we're not seeing print line name here. So did it fail here? I'm assuming it did. Like before we got there, yeah. So it panicked at line 83, and that came from kind of hard to read. All right, one way to do this is to say unwrap here. Alphanumeric string and E. Oh, yeah. Okay, well, that doesn't work because it's expecting the type information from here to be specified. Otherwise, it doesn't know what these are. So if I said name was a string and input was a string, then maybe I could do that. Oh, that needs to be stir like that. And then instead of getting a result, I can unwrap it. Type must be known to this. Okay, well, this is not helping. So let's go back to this one and see what's happening. So I liked the take until. Maybe I could just take until line ending, and then the name is going to be wrong, but at least it would work. That needs to be called with input. Let's see, take until. Oh, it definitely wants a string there. Okay. So name is seed to soil map. The second one is name is seeds. Okay, let's continue this. Let's do space map and just see if that works. So maybe it was the line ending that was messing it up. Okay, seed to soil. That's exactly what I wanted. Okay. So we parse the seed to soil. And does this test pass? 2 failed. So this one still failed. This one. Okay, yeah. So the very next character here, we want to say that this is terminated with a line ending. Otherwise, the very next one, on the fold mini, won't work. And I thought that's what I had. Oh, now I understand. Okay. Take until stops the parser. It doesn't eat this. So that's what, yeah, okay. So what we want is a alphanumeric 1 terminated by tag map space map colon terminated by a line ending. Okay, that makes more sense. Okay, so alphanumeric did not grab the dash. Let's see, how do I want to do that then? Take until white space. Let's take a look at the, I have this choosing a parser document that can help here. So I could do take until space here. Take until space. And then this one would be take till line ending. No, take till takes it. I think that's a function. So if I did take till new line, take until new line, and that's terminated by line ending. I wonder if this would work. A lot of these things, I think, could be simplified quite a bit. All right, so can't compile. New line isn't working. Is this the right one? Source character complete new line. That's the one I was looking for. Line ending. That's what I wanted. Take until line ending, terminated by the line ending. The thing that I don't understand is that yeah, sorry, these are not the functions I was thinking of. Okay. I was thinking this is one I could use inside of take till, but that's not what I want. But that's not what I want, right? If I do take until space, that will give us everything before the map. Okay, so this is the one that we're on now. Let me just run that one test so we can see it. This is going to be our source map. So it'll only match that one test, so it'll be easier to read the output. Let me allow dead code to get rid of some warnings. Do I do that on the type itself? Probably. Okay. Unused imports, let's clean up those. Line 62, parse input. We don't even need this function. All right, name is never read on source map. Let's do allow dead code because that will be fine for now. We also want to derive debug, so it'll print easier. Parse seeds is never used, which is not really true because I'm using it in the test. Oh, it's never used in this run, I guess. Okay, name is seed to soil. Then it panicked because the rest of the input was 50, 98, 2. Okay, so let's look at the rest of this. So did we get any of these parse ranges? Looks like no. Let's write a test for that. Let's do test here. Then we will grab a couple. We just need one. I think it's fine. All right. So our input, input equals this, followed by a new line. That part is important, right? Because this parse ranges eats oh, that may be why. Fold many parse ranges. I don't think I want to terminate that with a line ending because we already have the line ending eaten by the first parser. Okay, now our test is running. So now our values are backwards here. So 50 is the destination, so that means 98 goes here, and 50 goes here, and 99 goes here, and 51 goes here. This is 50, 52, this is 98, 100. Let's see, left is 100, right is 50. So that is the first one. Okay, so what happened here? 98 should be mapped to 50, but it got 100. So again, I'm going to go back to testing the ranges just to make sure we got the range correct. Test parse ranges. Okay, here we're going to say let ranges equals parse ranges on the input. We will unwrap the result and take the first element, which will give us our two ranges. And let's do R1, R2. And then we will assert equal that R1 is equal to 52 up to and including 50. Oh, that's 48. I don't want to do. Let's do 4. Well, 48, that gives me a 100. Okay, 52 to 100. And then the next one was range 2 is 50 to 98. Okay, that works. So back to parse source map. That is on line 86. Yep. Okay. So what we would have expected is that 98 becomes a key and that the value on that key is 50. Okay, so let's go to parse source map. We no longer need to print the name. Here, let's print out the pair, range pair, debug. And I don't need to label it if I use debug. Let's borrow. Okay, so we got 50 to 52, 98 to 100, which is correct. And the next one was 52 to 100 and 50 to 98, so that's correct. Okay, so then when we put the values in up here, I think what I want to do is change the order that we zip. And then I'm going to print debug inserting range pair. Value partially moved here. should be able to do that. Oh, not range pair. Pair. That's what I want. All right, so it's inserting all these numbers. So the first one, inserting 98 goes to 50. Did it override it? It did. Okay, that may be either my test is wrong. So 98 goes to 50 here, but in the second one that we parse, where is it? Where's the other range pair? This one. 52 to 100. And this one is 50 to 98. So yeah, I think it overwrites it. Let me read the input here. Seed number 98 corresponds to soil number 50, 99 to 51. The second line means the source range starts at 50 and contains 48 values. This corresponds to destination range and also containing 48 values, 52 blah, blah, blah. So 53 okay. 98 should be 50. Okay, I definitely have a problem here because it shouldn't be overlapping. Is my input correct? 50, 98 to 52, 50, 48. If I didn't have this line, it would be fine. Let's figure out what map it created. Source map. All right, so here is the map that it created. Unfortunately, it's not in order because maps don't preserve order. You know what? My ranges aren't correct, right? Because this one is adding count. This needs to be -1. Or I don't have a range inclusive. I just have a range. I think that's probably better. Import range, standard ops range, yep. See where else I'm using that. We don't need that one. Okay, where else are we using it? There, that's it. Okay. So now when we insert this, we go just up to the number, but not including. And we also have an equals here. Okay. Okay, so now we're failing. Sorry, we're still failing at the same spot. If I get rid of this line, then our seed to soil map is 98 corresponds to 50, 99 to 51. That's correct. 98 corresponds to 50, 99 to 51, and then this one doesn't parse correctly. If I add this one, then 50 should correspond to 52. And then when we go to the very end of this, it's 97 here because it doesn't add. That's why. Yeah, okay. That was my mistake. I had a problem here. So 50 plus 48 is 98 minus 1. And then that ends up being 99, I think. Okay, that passes. Okay, so now that we can parse all of our input, we want to find the lowest location number that corresponds to any of the initial seeds. And now this part should be fairly easy now that we've done all this hard work. Okay, so we've got the source map. We can take the seeds and we can source map. No, we need to parse the seeds as well. And that should be here. Seeds equals parse seeds on the input. Dot unwrap dot 1. This also needs to be dot 1, so we get the actual value. So now I've got seeds in the source map. We're going to find all of the seeds to soil locations. So we'll map the seed to source map dot. Oh, I already had a function that was doing this. Let's move this into the function. Source map. Oh, we already do that. So we can say source map dot find lowest soil number for seeds. Soil num, and then we'll do this soil num. Okay, let's go back over here and we will run all of the tests. So that'll be part 1. We can get rid of some of our debugs. All right, we're panicking on input now. So this one now, sorry, not that one, this one. Where's this guy? Panicked on input space 79. This one needs to parse process on the input. What happened here? I think I'm missing an extra new line. Because seeds will parse until the end of the line, and And then I need to eat this new line, I think. But it does say that the input is here, which means it got the seeds colon, but not the rest of it. So I think that the reason is because of this new line that should be at the end of this. But this still passes the test. So we have a seeds colon followed by one or more spaces. Then a space separated list, which does not include the new line. So I think I just need to add, terminated on the whole thing to add in the line ending. Parse seeds still works, and then I think what I need to just verify on the parse seeds part is that this was completely consumed. There was the all-consuming. Let's do all-consuming returns a result of the child parser only if it consumed all the input. Okay, so I think what we could do is all-consuming parse seeds input and import nom combinator all-consuming. Okay, this one is okay, so it still works. Okay, so if I got rid of the new line here, it shouldn't parse. Okay, perfect. So now the next problem is that we have a new line after the seeds. So I think what I want to do is just do terminated parse seeds with another line ending. And then call that with input. Okay, so parsing sample input or testing sample input still failed in the exact same spot. Let's go back to the sample input. Maybe there's an extra space that I'm missing. Seeds, colon. So that's one new line, then the second new line, then it should be fine. So the code was tag. I don't know if that means that so we're here, parse seeds, terminated tags seeds by one or more spaces. Hey, Samuel. Good to see you. Thanks for joining the stream. I am trying to debug why my parser isn't pulling out the right data. The data looks like this, and it seems like we grab everything and then fail on the space. And I'm not quite sure why. So in parse seeds, we've got this tag seeds terminated by a space, one or more. And this is one thing I'm not quite sure how to, like, I wish I could say, does this part work? Because I have a test for just that one thing. Just parsing seeds, and that works. Let me try this on test parse seeds. Parse seeds failed here. Possibly because it's all consuming, but let's do terminated by a line ending. Or I could do a tuple of parse seeds and line ending. No, but that will return the thing we don't care about it. So terminated is what we want. Line ending. I need one more. Okay, test parse seeds is okay. What is the difference? I copied this whole thing, and that's working. Test sample input. So we call process input. We're doing terminated parse seeds by line ending and unwrapping it. Oh, so this seems to work. Print. Let's debug seeds here. Maybe I'm looking in the wrong spot. And seeds. Okay. Yeah, I guess I was wrong here. Input 791455 is that one of the locations here? No, it's not. 791455. Super strange. 791455 is only that first one. What is happening? All right. All right. Now I know what happened. Okay. Damn it, man, I lost a lot of time off of that one. Okay, so the problem is I'm passing input to this and parsing seeds, and then I'm passing input here, and it's not going to recognize it because that's not what that should look like. So what I really need is either to grab input here, like this, and not do the dot one, and now I have it here, and then that should parse. It may still fail, but at least it won't parse. Or sorry, at least it'll parse. But now that I'm getting a little bit more comfortable with this, I think what I can do is do seeds and source map equals, and I'll do a tuple parser with this one, get rid of that, and then parse source map. Then call that with input and get the first element, which means I don't need that anymore. Tuple terminated. I think I need an actual tuple inside of here, which makes this like that. Then we call input and unwrap it and call .1. Okay, now we're moving. Okay, so the lowest soil number, finally. Let's go over here. So I'm going to, let me get rid of that. We're going to take all the seeds. We're going to iter.map those and find that in self has a map. The map is no, we need many maps, right? Because parsing source map is only going to give us one. So what we need to do is grab many of these. So I need a what is the overall thing we're doing? Planting seeds. So basically I need something to hold on to all of those. That's what I haven't been doing. So instead of parsing just one source map, I can do many. I think I want to do fold many, which takes the parser, then it takes the data structure. And then the function. So this will be the accumulator, which will be the maps. And then this will be the source map. And then we will, maps needs to be mutable. We'll return it at the end. And then here we're just going to say maps.insert map source map.name and source map. Okay, where's that seeds.iter? Okay, so now this is going to be source maps. And so that's not going to make sense anymore to find the lowest soil number because we need the right source map to find the lowest. So let's just do that here. Let's get rid of this method. Let's make sure that we're getting something. Cannot find soil num. Let soil. Well, okay. So now let's let the seed to soil be source maps of seed to soil dot map dot get. Well. That's the seed to soil map that we need. And now I can say seeds.iter.map each seed to its soil position. So that's going to be seed to soil.map.get for that value here. And then we want the minimum. Soil num. Okay, option U32 is here. We want to unwrap it here. Should have one. And then we want this to be dereferenced. Is that right? Option, oh wait, sorry. This one, we expect this to be here. Unwrap. Okay, source maps cannot be moved out. Move occurs because the value of source map, which does not implement the copy trait. So we can tell it to move into the block, and I think that's fine. Variable defined here returns a reference to a captured variable by the closure body. Oh, okay. This makes perfect sense now to me, which means that I'm getting better at this. So we get a reference to the source map that's inside of this hash map. So we have a reference to it. Then we, a move isn't what we need here because we're referencing this and then getting a value inside of that thing. That returns a reference to the element within the map. So somehow we either need source map to be copy or we borrow. Yep. Okay, called unwrap on a none value, line 18. So we don't have... Okay, so this one is the case where there's a seed location that we haven't mapped, and they said that if there's no map, sorry, if there's no value there, sorry, unwrap or, and then I need to give S here. Unclosed delimiter, mismatch closing. Do I have too many? One here, one there. Yeah. For one that we don't have a reference to in the input, it just passes straight through. So the seed index, 1 becomes 1. So now we are expecting 35. What was the number that they said? Lowest location number is... Okay, so this is what we need to look at. These are the numbers. Gardner and his team want to get started. Find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through the other categories until you can find its corresponding location number. Oh, okay. It's not just the soil number. Okay. What was the input again? Soil, humidity to location. Okay, so I need to go through each one of these. All right, this one's fun. All right. So we can't do this. I need to kind of iterate through. So if I do, let's see. I mean, I could probably iterate over all of them. Something like seed to soil. Yeah, I think I'm going to have to do that. So this is going to end up being a how do I want to do that? If I took a for map in, and I did the whole list. So this would be like seed to soil, then soil to fertilizer. Soil to fertilizer, then fertilizer to water, fertilizer to water, then water to light, then light to temperature, then temperature to humidity, then humidity to location. Humidity to location. Okay. So now I've got, this needs to be an iter. Okay, so now for each one, I need to find the index into the next thing. So starting with, let's say let mute index equals, we're going to start with each seed. So this is going to be find the location for a given seed. So let's say that the index is seeds 0, just for now. Then we can say index equals map.get index unwrap or index. So that will give me the index to the very end. So now I can do seeds.map, seeds.iter .map s. Then all of this goes in here. There's probably a way better way to do this. Let's pull the vec up here. So this is going to be let maps. Index is s. So then, no, I think I need that to be here. How do I want to do this? Because I want to keep iterating over all the maps, transforming that index into the next one. I feel like there's a flat map in here somewhere that I could do rather than doing the for loop inside of the map. So given this position, because I need something to keep track of that, and I already have it here. So this ends up becoming maps dot fold, maybe? That actually could work. Maps.iter.fold. The initial value is going to be s. Then the function is going to be index, which is going to be mutable, and the new map. So then this is going to take map on the current index and return it. That does not need to be, because I just need to return the new one. So this needs to be unwrap or map.get at the current index unwrap or index. And I think these need to all be references. Okay, so that will give me the seed all the way through to the map. Then I can take the min and unwrap it. Okay, this ends up becoming a vec of that. Let's map this to their actual maps. So that's the iter.map to source maps. To source maps.get name dot unwrap. Expect format missing a map for name. I don't need to do that because that's already a string slice. Expected a string. Oh. I don't think I can do this because it's got to be. That's fine. We don't. We'll just say missing a map and see what happens. Okay, private field, not a method. Okay, maps is here. Oh, we're already an iterator. Okay. Let's dereference it here. Let's see, method not found in source map. Oh, I need to call map.map, which is a little bit weird. Let's call this source map. Don't need the index anymore. Cannot move out of maps. If I do move, captured variable in a function mute closure. Maps is a captured outer variable. Move occurs because maps has that type. It does not implement the copy trait. Not quite sure I understand what's happening here. Fold takes ownership of the receiver self, which moves map. One way to do it is to clone the maps here. No, sorry. Here, maps.clone.fold, which is not really what I wanted. Okay, this is freed while still in use. Do I need the move anymore? Don't think. Temporary value dropped while borrowed. Okay, so we create all these maps. And the borrow later captured here by the closure. Consider using a let binding to create a longer lived value. I'm not sure why this matters. So if I have the vec as this, let's just call this map names. And then we can say maps equals map names dot iter dot map. And I don't think, okay, that's weird. I'm not quite sure why those two things weren't the same. Yeah, that one's weird. I'm not quite sure. Okay, so we're missing a map. Seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. Let's just do debug name here. So soil to fertilizer we're missing. So let's make sure I spelled everything correctly. So I wonder if it's still only parsing just the single one. So processing here, source maps here. Let's say print source maps. That's print line. This is going to be source maps dot keys. We can do the debug formatter. Source maps parse seed to soil. Okay. It contains this new line which we don't want. So in the parse source map, here we're taking all of that, then the fold many, yeah, so this parse ranges. In between each one of these source maps, there's an extra new line. So let's do that here. This parse source map needs to be terminated with a line ending. Okay. Now we have source maps parsed, panicked, missing a map, so we're still missing one. Probably because the end of it does not have one. We're looking for humidity to location and we don't have that one. Is there like a maybe line in? Maybe end of file is another one we could look for. So let's see. Let's look at the non-parsers again. One of. That's characters. The first successful one. So I think we could do that. Alt, line ending, and EOF. Yep. Let's see. Non-branch alt is not. Non-branch alt is not implemented for results. Oh, it's got to be a tuple. That's why. Okay, and now our test passed. Yay! Let's try this on the actual input. Let's go to bin part 1. Bin / part 1. Make sure we include stir input.txt. Then we will grab the input, copy. These are some big numbers. Save that. Save that. And now we can do cargo run -- bin part 1. Seems to be taking quite a long time. I could do it on the ranges, let's say. See, debug, parse ranges, input. Feels like I have a infinite loop somewhere. So parse ranges, I made it here. Parse source map. I have the name. Let's close that. I could do debug, name, and range pair here. You know, I think inserting every single entry is a mistake. I should just contain the ranges. Yeah, I should just contain the ranges. There's no reason to store every single number. That's why we're having a problem. Okay, I suppose I should have looked at the input first, but okay, so our source map, instead of being a hash map of U32s, this is going to be a vec of ranges. Range U32. So we'll have multiple ranges. This is going to say ranges, maybe? Wait. I need a destination range too, right? Source and a destination range. Yeah, so this is going to be a tuple. Let's make another type. We're going to call this a struct range pair. We will derive debug. Then this is going to have a range, a source range, which will be a range. We can make this generic if we wanted to. I don't care, honestly, because then I have to make it comparable or something. Or, yeah, I think I'd have to make it comparable. I don't really care about that. So I have source and destination range. So if I've got a vec of range pairs here, that becomes ranges. Okay. So then when we're parsing, these are like that. When we're parsing the source map, parse ranges is fine. Parse source map is going to fold many, and now we get our range pair, and this is where instead of doing map.insert, we're going to build a range pair. Yeah, we don't even need to zip here. So here we're going to take, we don't want to fold many into a map. This becomes a new vec. Ranges. And here we do ranges.insert. Insert range pair with range pair.0. Source range is range pair.1 actually. And dest range is range pair.0. Okay, we've got a whole bunch of stuff wrong here. That then becomes ranges. And then here, this becomes ranges. I think this is no longer a fold many, it's a map. Let's see, how do we do that? So if we do fold many, I think I can just do many. If I do many parse ranges, let's just get rid of that. On input, like this, then the type becomes vec of range 32, range 32. And I just want to map that now. Is it flat map? Flat map ranges. This is going to be a range pair with the source as ranges.1, a destination of ranges.0. Does that work? It does. Okay, sweet. Then we do that. All right, so let's do just watch part one. So we run all the tests. And now it's time to clean up all the stuff. So if we look at map, anytime we're doing here, so this one is now going to be, let's do an impl on source map. And we want a function get, which is going to get the index. This is going to be get an index. And it's going to return an option of the results, U32. No, it will not return an option. It will always return one. So here we can then say ranges.first. Sorry, this needs to be a self method. Ranges, self.ranges dot first where find iter.first find. Pretty sure that's what I want. What is find? Any of them return. It will stop processing. Okay, perfect. So we're going to find a range that contains this number. So r.contains range pair. So r.source.contains if that works. Let's see. That contains this index. So that will find the range pair. And then I can map on the option range pair. And this will give me I don't know how I want to do this. Because what I don't want to do is zip through all the numbers. That was the problem in the first one. Okay, we're close. We can get the offset. Let's do this in a couple of lines. So let offset is going to be range pair dot source dot lower bound or min. What is the start? So we have the start of this range. We can do index minus that to get the start. And then we can do the same thing on, so here we're going to return range pair dot dest dot start plus offset. And doing that, that should give us then the actual number if it was contained. This returns an option, so we then can do unwrap or and just pass the index back to the caller. Okay, we still have that. We need a lifetime parameter here. Impl tick A for source map tick A. Line 28. Soil numbers. Okay, so we go through each one. Yada yada. Seeds.iter.map. Source maps dot map. Source map dot get. So that can just be a get now, and we don't need to unwrap or anymore because that will always return one. Start, remove. It's a field, not a method. So can I do that then? Unwrap or index. Arguments to this method are incorrect. Oh, it needs to be option. Not option, a reference. Unwrap or index. Expected empty tuple. Am I in the right place? Yes, 50. Okay. R gives us a, the find gives us an option of range pair, an option to a reference of range pair. Then we map that and get this. Oh, that's why. Semicolon. And now it wants wait a second. Expected U32 found. Sorry, index is already, sorry, yeah, okay. So I need to do a star to dereference it. Now it's saying it expected that. 58. Is that the right place? Oops, not that. This. Here. Okay, so we either need to return one or the other. If I can return that, it should be fine. Source map.get. Expected U32, found U32. Consider borrowing. That's here. Ranges.1. That's here. Is that right? 89. Parsing ranges should return the two ranges. Ranges.1. Flat map ranges. Oh, that returns the entire vec, so then I need to do ranges.map. Range. I'm just going to do R, and then that'll be R.1, R.0. Map exists. I need to do ranges.iter.map, which means I really want that to be on its own line. Sorry, here and there. Okay, and let me back up a bit. I want to see what I'm doing wrong here. So if I look at the type inlays, ranges gives me a vec of, I was expecting that to give it to me for each one. But it's giving to me the entire results. So let's look at the docs for flat map. Create a second parser from the output of the first one, then apply over the rest of the input. Let's see if we can find an example of this. So if I do let input x equals many one parse ranges, and I look at the type inlays, it's a little confused now. And that also needs to be question mark. Ranges. What is the type here? Okay, vec is a vec of range pairs. How is that possible? This doesn't return a range pair. It's totally confused. That needs to be called on input. Okay, now we have input and then ranges of vec of 32. So this can then be mapped. The thing that I just don't understand is I thought I could map the results of that. If I do this now and I say flat map and I say ranges, that gives me the entire vec. So then ranges.map, ranges.iter.map. And if I just map to, you know, a string or something, then call that on input. It doesn't like that because it expected this closure. Yeah, I'm not sure. I'm just going to map it at the very end because I don't want to spend too much time on this. So if we do this now, we get back that, and then I can map this to their range pairs. So ranges becomes ranges.iter.map r range pair with a source of r.1 and a dest of r.0. And then that needs to be collected. Iter range. Now I get this range pair. Expected a vec range pair. Found a map. That is the end of the map. Oh, this is wrong. Then here. That's the end of that. That's the end of that. That is end of source map, the tuple, and then the OK. And then the parse at the very end. Okay. Goodness. Unused import parser. Okay, part 128. Cannot return a reference to a temporary value. So when I call get, it's returning a U32. Do I not need to do that anymore? Expected U32 found U32. Consider borrowing. Source map.get index. This returns a reference to data owned by the current function. Is that because we're cloning and then folding? I feel like I shouldn't be doing that. So that gives me a U32, but I can't do this because then that's sort of what it's saying. Can't return a reference to data owned by the current function, which is true. Don't I want to say star index equals this? But then what do I return? That doesn't really make sense either. Because it should be returning the item. It says consider borrowing here. Mismatch type source map. Expected a reference U32, found U32. Where's S? That's here. That fix it? Because then I'm no longer returning a reference, I'm returning a copy. Let's fix the other errors first. So these all become that, and then they're no longer optional. And then they return an own value. Okay, cannot move out of, let's see, ranges, range pair. What do I need to, I think I want into iter here. Yeah. So the reason is if we iter, we're just iterating over values that are owned by the ranges type here, the ranges variable. If I do into iter, it converts each element into its owned type. So we no longer can use ranges because it got converted into an iterator, but now we can pass these values around. Okay, now everything is working. If we run it now, we got an add with overflow. So I think that these numbers now need to be U64. So find U32, and we're going to replace with U64. U32, replace with U64. Okay. All right, source maps panicked at line 25, missing a map. Okay, so which one are we missing? We've got water to light, light to temperature, temperature to humidity. We don't have the last one again. So let's look at our input. We're super close. So we should be getting end of file here on this last one, which is humidity to location, and that's the one we don't have. Thought I fixed that. So here, terminated parse source map, alt, line ending, or end of file. Let's do debug remaining input. So we still have some more data here. The line that starts with 216 is what we're remaining. So interesting. Input is new line, then humidity to location map, which is not what we want when we start parsing the next one. So when we do parse source map, it's interesting that that's only happening on the last one. There's only one space between each one. Interesting. Okay, so let's go to the top. Remaining input after parsing the first one. Yeah, I think that parsing the source map should probably eat the following character, because it goes to parse ranges, parses a bunch of ranges. The ranges end in a line ending, and then there's another line ending after it, which I thought we were doing at the top here. Here. Parse the source map, followed by a line ending or an end of file. So after parsing the first item, we're left with this new line, which is wrong. If I get rid of this, or if I just, let's just say tag %, which isn't in the file. I just want to see if we are seeing the same results. At the very end, where we're missing the same exact one. Missing a map, we're missing, yeah. So the end of file, yeah, we have two problems. One is we need to eat one more line ending. Let's do it like this. Maybe for line ending, I could do many one line ending, which would get one or more line endings. What did I do here? Many one line ending. Cyclic type of infinite size. That's funny. Note the full type name has been written here, which is kind of funny because it's too big to fit in the debug output. Okay, I don't know why I didn't like that. Back to this one. Missing a closing delimiter. Still not seeing it. This is what we need. Okay. Maybe that's what I was missing. No, still no. So this one closes the fold many, which is not what I want. I want that one. If I did it like this, this is the error we're getting. Still not eating this extra one here, which I don't like. Because I think even the first one has it, the seed to soil map. Oh, it's interesting that the name ends up fine. I want to do the name and then the input so we can see a little bit better. So the name was seed to soil, and then the remaining input after that is all this stuff, which seems fine. And then if I go down to the next one, so it's pulling out the name fine, which is interesting because I thought the input started with a new line. So we go down to the very end, humidity to location. The remaining input looks like this and ends the string. So did the parse ranges end up failing on the last one? Because it gets the humidity to location name. Yeah, let's look at parse ranges now. There's no line ending here. That's what we need. Line ending or you end of file. Because the range ends there. Yeah, I think that's what we want. In parse source map, we were expecting that to be end of file or line ending. We're not going to get this on the last one.
because we just want to parse source maps and have optional line endings. I wonder if there's an easy way to do this. No results for optional line ending. Separated lists could maybe do that, but then we're doing fold many 1 on this. So this is fold many 0. Applies the parser 0 or more times, folds the list of the return values. Fold many mn. Applies the parser between m and n times. Okay. Yeah, I don't know what the best solution is here, because we're parse source map it now is going to eat the end of the line because of the ranges. When we parse the range, we're going to be eating the end of file. I'm kind of curious if that will work. Terminated parse source ranges alt line ending end of file. Let's just see what happens. Alt. That's here. This takes a tuple. It works. Okay. Answer is that. That's the right answer. Man, that was a little painful. Getting better at nom, but only slowly. Okay, everyone will starve if you only plant such a small number of seeds. Reading the almanac looks like the seeds line already actually describes ranges of seed numbers. The value of the initial seeds come in pairs. Within each pair, the first value is the start of the range, the second value is the length of the range. Okay, I think we could do this, and so let's do our dance about duplicating all these files. Duplicate. This will be part 2. Lib will have pubmod part 2. Duplicate this one. Part 2. This one will say part 2. This one will say part 2 also. Okay. So now if I do just watch part 2, we should be able to run it. Okay, part 2. So now in the parse seeds function, this is now going to return a vec of range U32, or sorry, range of seed. Which means that our separated list of numbers needs to be iterated in pairs. Which means I think this whole thing is a little bit different. So seeds, okay, so this one, instead of being a separated list of space 1, this one needs to be a separated list of space 1, and then this is going to be a tuple. I don't think we have pair, do we? We do. Gets an object from the first parser, then gets an object from the second parser. So tag ABC, tag EFG. When we call that on ABCDEFG, we get nothing, and then we get a tuple of the results. which is kind of what we want. Okay, so this one is not going to have the space. It's just going to be this one and this one for the pair. And then those are going to be separated by spaces. Okay, so looking at this a little closer, we'll pull out the pair. This one will eat the space, and this one will be the second one. That's going to give us a... So here I think I flat map this, and I should get the pairs. And that is a vec of U64, U64. So this needs to return then pairs.iter.map. P, and this, so now I have a pair, and this is going to be a range from P dot dot P dot 0 dot dot P dot 1. Don't know if this is correct, but let's start at the top. So now when we do get on, so our seeds can no longer be index. Where is that? The seed, this is actually going to be quite a lot, because I'm just taking that and I'm doing that this many times, 56 million times. I wonder if now I'm supposed to be working backward to find the smallest location. No, but then what if it's not contained in that? I really don't want to iterate over that a million times. That's kind of the problem that we have here on line 28. When we call get index, so we're iterating over the seed ranges, and we'll get a range. Then I need to get all the elements in that range. And then get the minimum one of that. This seems like a terrible idea. Okay, yeah, I'm out of time. So I'm going to finish part 2 later, perhaps tomorrow. Not quite sure yet. But thanks for watching, and I hope to catch you in the next one.